Hey, what's up YouTube and welcome to some sort of tutorial video where I'm gonna try to show you how I did it. Perfect, so in the previous devlog what I shown is that I was able to connect my game server, my game client and everything with Steam and Playfab. Some people got interested on how I did it, and I think that makes sense because I didn't find a lot of information about this on the internet. I think the best thing I can do is to share with you the information that I've learned. So with that video, I hope you're going to be able to use this information to build something and maybe do better than what I did. Disclaimer though, this is my first game dev project. This is also the first time I play with Steam API and Playfab. I'm making this video to show you how I did it in details. It doesn't mean this is the best way to do it. For example, I did not use the lobby system from Playfab, which I could have, but I decided to create my own lobby systems. I might change it to use Playfab at some point, but I don't know yet. For now, I'm gonna show you what I did. Alright, let's start with a new project. I'm gonna be using Godot for this tutorial, and you might notice I'm using Godot with Mono because I'm a C# developer, but don't worry, everything that we're gonna see today is really easy to understand and really easy to just translate to GDScript. Nice, so before we jump into the project, I just want to put the basics on how the client and the server will work. This is not a peer-to-peer implementation. We are going to work with a server and client implementation. What it means basically is that the client won't talk to other clients. What we want here is to do only the communications between the server and the clients. By having that kind of implementation, you ensure you have a better security, and you also ensure that each client cannot have the IP address of other clients. That being said, let's start with the new project. If you're here, I assume that you already have the knowledge to create game server and game client. For that reason, I already created a basic game server and game client implementation, although I will do a quick tour of what I did because I think I'm doing some interesting stuff with my projects. Cool, so if you look at the file system on the left, you will see that I have a main scene, a game server and a game client. My main scene has been set up in the project settings to be the main scene when I run the application. The reason I do it this way is that I like to have both the client and the server in the same project. This way I can share a maximum of code between the client and the server, and I can also avoid to have multiple instances of Godot opened. Keep in mind that this is not mandatory at all. You can have the server separated from the client, and this is just a personal preference. Sounds good? So on my server I have a basic view with a label indicating a server and a simple button that will eventually launch this client. This is again just a simple view with a label. Let's have a look at the code now for this basic project. Let's start with the main scene. What we have here is a basic script that when the application starts will decide if we go either on the client or on the server, and this has been done using the function as feature. So when I create my build for the client, there is an option under the features tab allowing me to just enter a custom feature that I can now look in my game. Cool, so before we jump on the rest of the code, let's have a look at how it behaves in the runtime. The main scene decides to launch the server, and when I click this button, the server launches the client that automatically connects to the same server. If you look at the peer ID of the client, this is the same as on the server. This is basically a list of connected clients, and we can add multiple clients just like that. Personally, this is what I like about how I did it, is the fact that I don't need to have multiple instances of Godot running to launch clients. I can just press the button and it connects to the server. Let's have a look at how I've done that. On the server side, I attach a script on the button click. Alright, so what we want to do in this script is to launch another executable of Godot with only the scene that we're looking for. So what I do basically is I gather information about the executable of the engine with this function, and then what I do is that I get information of the path of the current project on the disk. This is what globalize path does. The only thing we're missing now are the arguments we want to pass to the executable. When we have all the arguments we want to use the function os.execute with the executable name, which is basically the exe of Godot, and then we pass the path of the project we are, and then the scene we want to launch. That's about it. What it gives us is this command line. So the executable of Godot, the path of the project, and then the scene we want to load. So yeah, this is basically what I do when I click this button to launch another client. The rest of the code for the client and the server is really basic, so I don't want to go too much in details into this one because again I assume that you already have this knowledge if you're here right now. You can see what I've done here. There is nothing to hide. This is just that I'm using the basic implementation of Godot to create the server and the client. So I believe that the reason why we're here today is to create an implementation of Steam and Playfab, right? So let's jump into this now. The way it's gonna work here is that we're gonna rely on Steam to launch our game, and then from Steam we're gonna ask him a login token that we're gonna send to our lobby server that we see on the top. This lobby server will give us the ability to create matchmaking and stuff for the players. Keep in mind that this is not the only solution. Playfab also offers the ability to do matchmaking and lobby server and stuff. So if you want, and I didn't explore it this way, you could probably get rid of the lobby server, but again this is not the way I did it. For now I'm gonna show what I did. Alright, so next what we do is we ask Playfab to start an instance of our server, and the way we do it is we create a Docker image with our server and we send it over to Playfab, and this is how the magic happens. Alright, let's start with the first step. The first thing to do is to register your game to Steamworks. This is basically what is required for Steam to know your game, and this is also the moment where you're gonna need to spend money. Steam requires you to pay $100 for every title you're gonna release. They do that to prevent people from just releasing weak games, and they're gonna refund you the $100 if you do $1,000 out of your game. So yeah, that's the deal. Also, registering to Steam is long. You need to send legal papers to show that you're a real person, so just do it the right way. If needed, just watch videos about it just to make sure that you understand it completely. Very nice. Now that everything is fine, you're gonna need to grab from your application on Steam your app ID, and from there we are ready to start programming and have fun together. Let's go. Well, I lied a little bit. We need to download the library first. This library allows us to talk to Steam API basically. I went with FacePunch Steamworks API, and this has been done for Unity, but it works for Godot as well. This is just some .NET library, so that works for Godot as well since we're using Mono, and that brings you to their GitHub page where you can download the zip file. Very cool. So back in Godot, what we're gonna do is that we're gonna create a new folder. I'm gonna call it libs. Nice. So open up that folder. Open also the zip file we downloaded earlier and locate the folder Unity. There is a 64-bit version of the file we are interested in, and just copy it over the new folder. Very nice. We're gonna need also another file from the zip archive we downloaded, and this is under this folder. Basically, the way FacePunch works is that this is a wrapper around the Steam API DLL. So you're gonna need the original DLL anyway, otherwise you're gonna get an error. So under Win 64 bits, you're gonna need the Steam API 64 DLL. So on our side, where you're gonna place it is under .mono. If you don't have that folder yet, just build your game. There is a temp folder, and from here just click on bin and debug and paste the file. That's it. Okay, so obviously this location is temporary and has been created by the build. When you publish your game, you can need to include this file as well next to the binaries of your game. Back in our editor now, we want to make sure that we include this library inside of our project. So I open the CS proj here and I add this item. Feel free to pause the video if you want to copy it. If you're using VS Code like me, you should probably reload your OmniSharp plugin so it detects the new library. Now open your game client, and under the ready function, what we're gonna do is we're gonna add a try catch because this function can throw an error. Inside of this try catch, we're going to use function from Godot, which is called os.alert, which allows us to just print a message. If something's happened, at least we're going to know what happens. Feel free to use whatever login function you have on your side. Alright, so we're going to use Steam Punch now. So this is steamworks.steamclient.init. This function expects you to type your app ID from Steam that I told you before. So go ahead. If you start your game now, you might see an error, so it just means that Steam needs to be launched. That's fine. Start Steam and start over. You just need to launch a game, and voila. You should see now the prompt from Steam saying that it runs, and you should also be able to press Shift Tab or your shortcut to open the overlay. And just like that, we run under Steam. Very nice. Next, we're going to request a hot ticket from Steam. This ticket is going to be sent over to our lobby server. I also keep a local instance of this ticket because Steam says that we need to kill the ticket if we don't use it anymore. This ticket should be valid for about 10 to 20 seconds. So by calling the function get hot session ticket, that will give us a hot ticket from Steamworks. That's nice, although this gives us a array of bytes, so we need to convert it to a string. So we're going to be using system.linQ, and then we convert each byte to 2 char string. Let's print out a ticket. This is just for now. We'll do something later on with the ticket in the video. If everything's fine, you should see something like that. Nice. So this is done. I think we can say that we have our Steam login. Now we need a lobby. Let's go. There is so many ways to do a lobby system. This is not related to Godot or anything. We're going to use this server to create matchmaking and also to hide our information that are related to Steam and Playfab. Both system has private keys, so we're going to use this server for that. Also, this is important that we have a bidirectional connection because the server going to need to talk to the clients and the clients as well going to need to talk to the server. So for this one, I decided to go with WebSocket. It supports certificate and it's easy to understand, so yep. Alright, so open up a console from wherever you want on your drive, and then type this command. So basically we call .NET with a new project, including the web API template with the name lobby server. That's it. I already created the project on my side and removed the stuff that we don't need, which includes like the weather stuff. This is a big part of this tutorial, so don't hesitate to just pause the video and look at what I did. I feel like it won't be really interesting to see me typing all the code, so instead I already created the project and I'm gonna try my best to explain you all the code I did in this project. Sounds good? So let's start with program.cs. I didn't do much in this one except for like the singleton that we do here for connections that we're gonna talk later on. Controllers and all this stuff was already there. This is really what comes with the basic template that .NET New creates. The next thing we do is to include WebSockets because this is what we're gonna use. So app.use WebSockets. And the last thing is to include a HTTP client with the line builder.services.add HTTP client. This is what we're gonna use to contact Steam. I think that's it for this file. The rest of it was already there. That's nice. So the next one we wanna look is the lobby controller. This is basically the code to handle all the connections and all the matchmaking and stuff. Keep in mind that this is a simplified version from what I did in my project, but everything here works. So yeah, I'm gonna show you how it works. So this is a basic controller for .NET Core, so it has a route and stuff. I also like to keep constants for my strings so it's easier to see when you open up a file, but really it's personal preferences here. I also keep the params name for the settings I keep in app settings like here, so this should be the same thing. We also have some dependencies injection that we get from .NET Core, like the HTTP client and the lobby connections that we saw earlier with the singleton. The next thing we have is the action lobby here, so this one is basically the login itself. Let's check that we are in a WebSocket connection. If not, we close the connection with the bad status code. If everything's fine, we get the WebSocket object and we try to authenticate the client. If we don't have a client, it means that the connection didn't succeed and we close the connection with the message. Else, it means that everything's fine and we handle the connection. Let's have a look at the authentication now. So in this one, we tried to get the Steam ticket that we sent over a custom header. If we don't have the ticket, that's a fail. Perfect, so let's validate the ticket with Steam now. Basically, we create the URL for authenticate user on Steam. This one should include the secret key that we generated from Steamworks. This is basically an API key. Steam also needs to know the app ID and the ticket that we generated. Next, we create the client and we send it to Steam. And then if everything goes right and we have a successful response, then we deserialize the content. I created all the classes I needed from Steam to make sure I could play with the deserialized values. The next thing to do then is to request information about the player because we want to know his name and everything. I do this by calling the get player summaries from Steam and by passing my private key again and including my Steam ID that I just gathered from previous call. The only thing left to do if the authentication succeed is to create a lobby client, and this one only contains information that we need. So basically the username, the avatar, the Steam ID, has the player been banned or stuff like that. Basic information about the player. Nice, so we're logged in with Steam. Back to the authentication method. If we don't have the client from Steam, then it's a fail. If the player has been banned, it's a fail as well. This is also the place we should have validated the client against a database or something like that, and where we could have gathered information about like his score or something like that, but I don't have this information right now, so I don't want to include a database now. And that's it for the authentication. I believe we're ready now to move to the Intel connection function. In this one, the first thing I do is to send to the client a welcome message so he knows that the connection has been successful. Right after, I start to listen to incoming messages. This is basically a loop that checks if the connection is still alive. When the server gets the message, we just deserialize it to a JSON object. From here, I have a small enumeration that lists all the kind of message I can receive. This is serialized as an integer, and this is basically the same thing for the messages that the server can send. So depending on the message type, I'm gonna do something different. In this case, for the start matchmaking, it means that the client has pressed the start matchmaking button and we send a matchmaking started message. I also have a flag is matchmaking for the client, and then we try to find a match. Basically, the way it works is that we try to find another player that is also trying to matchmake. For that, we use our lobby connections that we injected, and this is a concurrent dictionary. We use that kind of dictionary because this could be accessed from different threads, so it's important to have something concurrent. The record has been added to this dictionary when the connection was successful, basically, and we also remove this connection when connection is over. Alright, back to our matchmaking system. When we find someone else that is also matchmaking right now and is not us, we send the message that the match has been found, and that's it. The only thing we're missing now in this lobby system is to create the instance on Playfab. We're gonna do it, but first we need to adapt the client to make sure that we can connect now with this lobby system. Also, make sure your project runs, so .NET watch run, and that will launch your project while watching your files to be changed. That's it. Alright, we're back in Godot now, and I modified my project to make sure it matches the new lobby server. The first thing I want you to do before we jump into the code is to add dependencies. So we're gonna need system.text.json, and the reason for it is that we use serialization and deserialization here. We're gonna need another one, which is Microsoft.C#. This is because we use dynamic types for serialization here. That's it. Alright, so the first thing I added is the lobby server host with the action lobby, and notice I'm using WSS here to use certificate similar to HTTPS. Next, I added a small label to make sure that we can see what happens, and of course the obvious next one will be the WebSocket client that we're gonna use to handle all the communications between the client and the server. That's nice. I got rid of the alert because we don't need this anymore, we know it works. I'm also gonna remove the connect to server for now because we're gonna need to wait until we find a match to connect to the server. Instead, we're going to connect to the lobby server for now. In this one, I create the WebSocket client. I also put the flag verify SSL to false just because for now I'm using localhost, which doesn't have a valid certificate. Next thing is to connect the WebSocket events to local functions, and then we can just connect to the URL, which is the lobby server host URL with the custom headers xteam token to pass the ticket that we received from Steam. Awesome. Next, the WebSocket from Godot needs to be polled every process frame, so this is written in their documentation. Very cool. When I click on the button, I just send a message to the server saying that I want to start matchmaking. For the WebSocket events, I didn't do much in most functions. The one we are interested in is the data receipt function. In this one, we get the message from the packet and then we handle the message. That's about it. The other one that is interesting is the server close request, and this is in this one that we will receive the details from why the connection has been closed, probably because the login was not successful. For the send data function, nothing fancy here. We just serialize the message and convert it to bytes. The final one is the handle message. This is really similar to what we have on the lobby server. Basically, I watch for any kind of message that we receive, and then depending on what message I do react. For example, I do write message on the screen. Nothing fancy again. Let's see the result of it. So notice that I'm still using the server to launch my client. This is just more convenient, but for now we just don't connect to it. In my main project, I'm not always using the lobby, so that's why I'm still launching the server. But again, that's more convenient. So here on the client, we have the client connected message. with the username. Nice. That will be the same thing for another client, which is really cool. On the left, if I click on the ready, I'm just starting the matchmaking. Awesome, I got the message. And on the other one, if I do the same thing, we got a match. We got another step completed. Awesome. The next one will be the start server. So we're going to start to include Playfab in our project. Alright, so first we're going to modify the server a little bit, and for that we're going to need to add a new dependency to our project. The one you need is com.playfab.c#gsdk. Alright, so now that this has been completed, I initialize Playfab. To do so, I register for a shutdown callback, which means that Playfab will have called me to shut down my application. And the most important thing to do with Playfab is to call ready for players, which tell the host of our server that we're ready to receive connections. I also look for this exception. Basically, I let the server boot if we're not in a Playfab host. The goal is to be able to continue developing our server without the need to be on Playfab, so we can work offline, if you will. That's about it. You don't really need to do much more for the server to work with Playfab. There is more you can do, in fact, but I didn't implement anything else. There is one thing we need to do as well on the server, and it's to close it if there is no more player, because we want to free the place on Playfab. The next thing to do then is to configure your export for the server. What I do is I create a Linux build. Usually you will filter the resources you need for the server only, but for this tutorial I didn't do anything. Now that this is done, you just zip the folder and we're good for the server part, for now at least. Alright, so the next step is to download Docker. This is what we're going to use to create our image to be sent over to Playfab. So if you don't know anything about Docker, feel free to just read what they say on their website. This is really a useful tool that we're going to use. Now that Docker is installed and fully running, what I like to do is to create a separated folder to store all the configurations and all the files. Go ahead and create a Docker file like I did here. This file doesn't have any extension. This is just a text file basically. So I open this folder inside of my VS Code, and what I also like to do is install the extension Docker from Microsoft. This is really useful and I really like it. Next, we're gonna open our Docker file. Basically, a Docker file is a series of instructions that we give to Docker. This is how Docker knows how to create your image, basically. Please don't judge my Docker file here. I'm not an expert, and this is my first experience in Docker as well, so you can probably do better, and that's totally fine to me. That being said, we're gonna start with a minimal Debian image. This is one that worked well for me, and it's supposed to be a small one, so let's take it. Next thing to do is to copy the server we created earlier, the zip file. If you look on the left, I copied this file next to the Docker file. There are other ways to do it, like create CLI to build the server and stuff, but I didn't do it. Maybe one day, we'll see. Next, we give the instruction to run Linux commands like install, wget, unzip, and everything. We download the server build for Godot. You can choose the version that you want on their website. Right after, we unzip Godot and we remove the archive because we don't need it to stay on the machine. Next, we unzip our server and we also remove the zip file because we don't need it. What I do next is that I move the content of my server next to the Godot executable. This is how it worked for me, so maybe you have better ways, I don't know. And I remove the folder server that I copied. I say that my working directory is the one from Godot, the server itself. The next line only tells Docker that we will use this port, so you should replace this with the one you use on your server, just like that. Perfect. And then the last line is to launch the Godot server with our server build. Now that our Docker file is ready, what we're going to do is build the image for this Docker file. You just right click on the file with the extension and it prompts you for a name. I just accept it. If everything's fine, you should see your image ready in Docker. Alright, so the next thing you do is to create your Playfab account if you don't already have one. And if you go under your title of your game, you will see probably this panel and you need to enable the multiplayer. When it's done, you can click on it, and this is where we're going to create our first build for our Docker image. You start by giving a name to your server. For the server details, we're going to go with container because this is how Docker works and we are under Linux. So you should see that you don't have any container for now, and this is because our Docker image hasn't been uploaded yet. Under the upload to container registry, there are private information that you should not share, so I won't. But if you open this pop-up, you will see like login and password and URL. So I'm going to show you what I do with these information. We are back under VS Code, and what we want to do here is to open up the terminal. So I click here and terminal. First command you want to type is docker login with your username and password and the server URL that you saw in the pop-up. If everything is fine, you should be logged in into your Playfab account after that. The next command is to create a tag with our existing image that we have that we created earlier. So the first parameter that you see Docker latest is the name of your Docker image. For the last parameter that you see, it's important that you respect the URL here. So Playfab requires you to have a specific name for the Docker image. And for the last command, this is Docker push with the Docker tag we created. That's it. If everything goes right, you will see an upload going on, and that's about it. Back to the Playfab configuration here. I can now select the image that Playfab sees that we uploaded. So this was Docker for me, and the tag was the latest. And I forgot to choose the virtual machine, so you need to select one. This is required. So next thing is to configure the regions. I usually go for 2 standby servers and 2 Mac servers. I'm not quite sure yet what I'm gonna put in the future for that, but that's what I choose. The last thing will be to configure the game port, and this is important that you remember the name you put here because we're gonna use it in the lobby server. This is the same port you put here that the one you exposed in the Docker file. Now we're ready to add the build, and this step is long. You need to wait until Playfab is ready. At some point you should see the deploying status on the right, and finally deployed. Awesome, we're ready to move to the next step. Back in our lobby server, what you want to do first is to install the dependencies for Playfab. So it's Playfab all SDK. This one includes the ability to manage servers and everything. So this is not the same dependencies as we have on the game server. So we are still in our function try find match, but what we do differently is that we deploy on Playfab now. What this does, it authenticates ourselves to the Playfab server by setting the private key and the title ID, and then we need to have an entity token. This is how we log into Playfab. And then the last thing is to request a multiplayer server. This creates an instance of our image on Playfab, so we need to pass it the build that we created on Playfab. The preferred regions here, I'm gonna pass East US and the session ID. Then if everything goes right, what I do is I create a message that I'm gonna send to all the players with the server URL and the server port. Remember the name of the port we created earlier on Playfab? This is where we need it. One last step in our game client now back in Godot, we need to handle the message. So when I have a match found message, I connect to the server using the URL I got. Same thing with the port, and then we just call the function. This one has been modified for sure to receive now the server host and the server port, but that's about it. We are now at the moment of truth, so we have a client connected on the left on the lobby server. If I matchmake him, it starts the matchmaking queue. Same thing on the right if I'm matchmaking. We got a match, and if you look on the top right, we now have a peer ID on both client, and we also have a server running on Playfab, so everything works. I think this is safe to say that we now have our start server working from the lobby server, and we can also play the game. So that's it, I guess. And this, guys, is how I connected my game to Steam, to a lobby server, and to Playfab. I really hope you guys enjoyed it. This was a big video to make. I tried my best to make it as fast as possible, so it's not too boring. Let me know in the comments if you enjoyed the format of this video. And on that, I hope you have a good one.